Okay, number 3 and 4. We have a situation where I have a box, it's pushed to the right with some force, um, and it hits some friction. So this is T equals 0. This is T equals 2 seconds. This is T equals 6 seconds. The force of the push doesn't change the entire time per the instructions. And we do have friction here. Okay, and they give me this graph. A, draw a free body diagram on the box being pushed on the frictionless surface. So this is the beginning part, and here's the graph that's given to me. Look at the velocity, it's increasing. Yeah. So if I have a free body diagram of the box, this is FG, this is force normal. They should be the same length, by the way. And here's my force of the push to the right. Okay. Sure enough, I have acceleration, so my velocity is changing. So yep, acceleration is positive. Actually, how about we just say acceleration is to the right and velocity is to the right. It's increasing to the right, right? Okay. Determine the acceleration. Well, I'm going to use the slope of the line between t equals 0 to t equals 2 seconds. And the slope is equal to 2 over 2. 2 over 2. So I get 1 meter per second squared is equal to acceleration. There is I. Double I. Force of the push. Well, sum the forces in the x direction, which is equal to mass times acceleration in the x direction, which is equal to force of the push. I'm using this free body diagram right here to the right or to the left. Right, here it is. That's the only thing going on here. So force of the push is equal to the mass, which is 2 kilograms, they told me, which is times acceleration, which is 1 meter per second squared, which we determined off of the graph, will give me 2 newtons. Determine, draw the free body diagram. Now I'm into part B. Draw a free body diagram of the box being pushed on the surface with friction. All right, so they told me that I have this force normal. I have force of gravity. The force of the push is the same, so I'll have the same length. They tell me it's slowing down. Well, if that's slowing down, what has to happen? This force of kinetic friction has to be larger than the force of the push because I have acceleration to the left because I'm slowing down. Sure enough, I do because of this negative slope. But my velocity is still to the right at that moment in time. I'm just slowing down, okay? All right, BI. This is BI. I want to know A. I'm going to find the slope between t equals 2 seconds and I'll call 6 seconds. And I find the slope to be 2 over 2, 4, negative 0.5 meters per second squared equals the acceleration at that time. Excuse me. I need to now know during that time, what is the kinetic friction force? Well, sum the forces. Now I must look at this. I'm going to sum the forces in the x direction, which will equal to mass times acceleration in the x direction, which is equal to the force of the push, which we found earlier, minus force of kinetic friction. I'm trying to find the force of kinetic friction, so move that over to the left. I get a positive kinetic friction force equals force of the push minus mass times acceleration. So force of kinetic friction is equal to the force of the push, which is 2 newtons, minus the mass, which is 2 kilograms, times negative 0.5 meters per second squared. So force of kinetic friction is equal to, becomes 3 newtons. Makes sense, right? Force of kinetic friction being greater than the force of the push. Based on the fact that it's slowing down, it's to the left. Okay. There it is. That's the magnitude. Directions to the left. Okay. Coefficient of kinetic friction. Well, what's the definition of kinetic friction? Now, this is triple I. Mu k equals question mark. Well, force of kinetic friction by definition is mu k times force normal. So I need to know what force normal is. Force normal in this case is equal to mass times acceleration due to gravity, because that's the only thing that's acting on in the y direction. So force normal is equal to mg, and I can just solve for mu k directly. So mu k is equal to the force of kinetic friction divided by force normal. And so that is going to be equal to 3 newtons divided by 2, and I think I used 9.8. And so, and that will be in newtons, and that will be equal to, where's my number? Yep, 0.15. Okay. 4, total displacement from t equals 0 to 6, delta x equals question mark. Area, area, area 1, area 2. Area 1, area 2. 1 height half times the height, which is 2 times 2 plus 1/2 times the height, which is 2 times 2, 4, and I get a total area of 6 meters. Delta x is equal to 6 meters. And they asked for the displacement. They didn't ask for position, because then I'd have to take that number and figure that out based on where it started, right? Kind of like what we had on our exam. Delta x equals 6 meters. Okay. Number 4. A person pulls a 20-kilogram box on a straight horizontal surface. She pulls with a constant force of 95 newtons at an angle of 30 degrees above the horizontal. At t equals 0, the box is moving at 1 meters per second. At 10 seconds, the box is moving at 5 meters per second. Friction is not negligible. I have friction. Determine the acceleration of the box. Okay, let's draw pictures. Person pulls a box. She pulls with a constant force of 95 newtons equals the force applied at an angle of 30 degrees above the surface. So, free body diagram, force normal, force of gravity, force applied, force of friction, and we're pulling it, so it's kinetic friction. Okay, so there we go. I need the acceleration of the box. I'm accelerating obviously in the x direction. I would hope you assume it's not flying up in the air. Otherwise, it would tell us something to that effect. So we must be accelerating that way. And velocity, well, they actually told me. They told me some things. They gave me, let's track mass is equal to 20 kilograms. She pulls, this force applied is equal to 95 newtons. What else did they tell me? At t equals 0, v equals 1 meters per second. I can call that the initial. And at t equals 10 seconds, the final equals 5 meters per second. I have time, I have v initial, I have v final. A, acceleration equals question mark. I'm going to use kinematics to find acceleration because I have 3 things. So I'm going to use A equals v final minus v initial over time. That's my favorite kinematic equation. 5 minus 1, that's in meters per second, divided by elapsed time was 10 seconds, and I find the acceleration to be 0.4 meters per second squared. That is the answer to A. B, for the force normal. I've highlighted that in yellow. So I have to sum the forces in the y direction, and that will be equal to mass times acceleration in the y direction, which I hope you see is 0 because it's not flying off the ground. It would have told me. I have force normal. I have one other force that's positive, and that is the y component of the force applied. So I have force applied times sine of 30 degrees minus force of gravity, because it's pointing down. This is 0. So force normal is equal to the force of gravity. Come on, stop behaving. No, don't tell me you're running out. No. Force of gravity minus, what is the problem? Minus force applied times sine of 30 degrees. Okay, so force of gravity, it's 20 kilograms. B. I used 9.8, so minus force applied, which was 95 newtons, times sine of 30, and I get force normal to be 149 newtons. B. C. Determine the coefficient of friction between the box. C. Sum of the forces in the x direction is equal to mass times acceleration in the x direction. All right, what do I have in the x direction? I have force applied cosine 30 degrees minus the force of kinetic friction. Did we find force of kinetic friction yet? Not yet. This I know though. We'll be able to find it, don't worry. We know the acceleration. So solve for force of kinetic friction first. And that is equal to force applied cosine 30 degrees minus the mass times acceleration in the x direction. And so we actually have a value we can solve for that value. So let's go ahead and do that. So that is 95 newtons times the cosine of 30 degrees minus 20 kilograms times with acceleration that we calculated in part A, which was 0.4 meters per second squared. That's a Newton. And we get that value to be 74 newtons is what I get. Well, what is the definition of force of kinetic friction? It's mu k times Fn. And so mu k is equal to the force of kinetic friction divided by Fn, which is equal to 74 newtons divided by 149 newtons. And I get mu k to be equal to 0.5, approximately. And this is the answer to C. Come see me if you have questions.